Welcome to Unit 6 Solutions, Lesson 1 on Net Ionic Equations, video number 1. So we have reviewed double replacement reactions. So just to go over that again, a double replacement reaction, when we write chemical equations, we know that most reactions take place in aqueous solution, which has that little AQ after it, which means that it's in water. So with that, we have to have where we start with two compounds and we end up with two new compounds. And we only have a reaction if we get one of three conditions met: a precipitate, a gas, or water. And we're going to go back over that solubility table that we looked at, and that review was just for some extra practice. So when we look at reactions, we're actually going to define four types of reactions. The first one is a molecular reaction. So in this one, the compounds or elements are written as whole units. So this is basically what you learned in Chem 1. So whenever we balanced chemical equations and predicted different reactions, they were all molecular. So you write them as a whole unit. So the compound is written, if it's salt, it's NaCl. It's table salt, sodium chloride. Or if it's iron 2 sulfate, it's FeSO4. There are different types of reactions though. The next one, and we'll be talking about this one and learning how to do it, is called a total ionic reaction. So in this one, compounds that are soluble, or we're going to say ionize in water, are written as ions. So sodium chloride, well, instead of writing it as NaCl in a total ionic, that dissolves in water. And when something dissolves in water and it's an ionic compound, it ionizes and forms its two ions. So we get Na plus and Cl minus, and we write them as that. So if you put salt in water, common table salt, instead of having NaCl being attached to one another, the ions separate out. And that's why a lot of solutions are able to conduct an electrical current, because we have a separation of charge. The third type is a net ionic reaction. So this is what remains in a total ionic reaction after spectator ions are removed. So a spectator ion, just like we'd have a spectator in a sport, they really don't do that much. They don't participate in the game other than cheering and providing support, but they don't participate in the game. So spectator ions are ions that don't participate in the reaction. And I'm going to use RxN to abbreviate reaction a good bit. So that means that it appears as a reactant and a product. So they appear on both sides of the equation, and we can cancel them out because they don't do anything. And then the last type is called a redox reaction. It stands for reduction, oxidation, and it involves transfers of electrons. And we're going to have a whole unit on this later on. So I'm just going to put later on in the year. It's actually one of my favorite units. So it's just looking at a totally different type of reaction and how to systematically balance equations. So We already did this review of double replacement reactions, so we are going to skip that with this, and we are going to move on to our next video.